Welcome to day 3 of the boot camp. This is the last day. It's a whirlwind. We're talking about automatic reports a little bit today, but unfortunately these slides are now completely out of date because R Markdown has been superseded by a new thing called Quarto. So I'm going to show you Quarto. Before I do that, I do want to talk a little bit because I rushed this terribly at the end of the first day. I do want to talk a little bit about plotting because plotting is a very important part of getting to know your data set. So I talk a lot in my class about exploratory data analysis, which is really just playing with your data, getting a sense for what are the variables that are included, what are their distributions, are there any outliers, are there things that I should know about this data that aren't immediately obvious. And a lot of that is going to be through plotting and visualization, right? Humans are not designed to look at a table or a list of numbers and immediately get anything out of it. And so a lot of the insights that you get from your data will come from plotting. To that point, I'm not going to go through ggplot. Honestly, I think ggplot is a powerful tool for like creating a final graphic when you've got a picture in your head for what you want to be visualizing, and you know, I want this color scheme, I want this like figure margin or whatever. But because it takes 2 or 3 lines of code just to make a basic scatter plot, I don't think it's great for exploratory data analysis. I don't think it's great for playing around with your data. So to demonstrate this a little bit, I'm going to go back to this diamonds data set that we've been using just because you're familiar with it. So that's from the ggplot2 package. I'm going to say data diamonds, which will give me this data frame, which has 10 variables all about particular diamonds. I don't know where this data set came from. But if we were looking at this, you know, probably the first thing we would want to know is what are the variables that are present in here. So we can look at the call names, which is the function for, oh, sorry, I should make this bigger. Is the function for looking at the names of the columns of a 2-dimensional data set. And so that's going to tell you all of the different variables that we have in this data set. Because it's a data frame, I could also just say names, but I wanted to be explicit because these are the names of the columns. You could also do row names, and I don't know that the rows have any names in this data set, but sometimes you'll want to put names with the rows as well as with the columns, and those can be like observation 1, observation 2, observation 3. If I do head, head is one of those functions that was carried over from like the old days. It's a Unix function. It shows you the top of something, or it shows you the first like 5 or 6 elements of something. So if I do head of diamonds, it'll show me the first 6 rows. And it actually cuts off some of the columns. But you can see this is now just a 6 by 10 data frame. If I wanted to get a sense for some of these variables, it would be totally reasonable to make some plots, maybe a histogram. So we look at the caret variable. We see that it's numeric, you know, 0.23, 0.21. What are the range of values? What are the expected values? We can make a histogram with the hist function. Diamonds $caret is how you pull out that vector of just the caret values. We'll make a histogram like this. This could be a very useful way to identify weird values, identify outliers. Sometimes you'll have negative values in places where it makes absolutely no sense to have a negative value. Histograms are great for finding those sorts of things. If we wanted to plot 2 things against each other, see the relationship between variables. We can do that with the standard plot function. And so maybe we wanted to do caret versus price, because that might be a reasonable thing where we would expect some level of relationship between the two variables. That'll make a scatter plot for us. We see that there is some correlation there, not too surprisingly. Plot, despite being a very general name, can really only do a couple things. It can do scatter plots and it can do line plots. So if we had a variable in the X position that was basically just uniformly increasing, maybe it was year versus some statistic from each year, then we might want to do a line plot. That wouldn't really make sense here, because these things are not in order necessarily. But is there one that is in order? Not really. I'll just say 1 to 10 and at 1 type equals L. I could also spell out line, but just L is enough for it to know what I mean. And so here I just plotted the vector 1 to 10 on the x-axis versus 10 to 1 on the y-axis, and you can see we get a straight line. If I remove this, it'll default to a scatter plot. Another one that I want to mention is bar plot, which makes a bar plot, not surprisingly. But we need a little bit of extra work if we want to look at some of these categorical variables. So color is, we see that it's a categorical variable. We've got different levels of it. E, I, and J are all visible here. And so a useful way to summarize something like that is with the table function. So table takes anything where you've got different values, and it just counts up how many of each value you've got. So if I make a table of diamonds, dollar, color, it'll tell me how many of each of those types I've got in the data set. And again, because I'm not good at looking at numbers and getting insights out of them, I'm just going to put that directly into a bar plot. And now I've got something a little bit more easily interpretable. For most, box plot is the one other one that I wanted to mention. Box plots are very much like histograms. They give you a sense for the distribution of values for a continuous valued variable. They're less specific than histograms because they're just sort of a 5-number summary. If I do a box plot again of the caret values, we'll see this again. It's a skewed distribution. We know that from the histogram. But the nice thing about box plots is that you can do multiple. You can plot lots of them. And so I'm going to take a little bit of a shortcut here and use some notation that you haven't seen before. But this twiddle is a common R symbol for when you're building models. And I'm not really getting into too much statistics here, but when you learn how to use the LM function for linear models in R, anytime you're doing any sort of regression model in R, you're going to use this tilde, that's the name of it. And it's going to be like y tilde x. I want the thing on the left to be modeled as a function of the thing on the right. And so I'm going to model caret by color and see if those things have any relationship. And it gives me a nice box plot of the caret values for each of those categorical colors. The nice thing about baseplot that I enjoy is that it's super easy to add extra things to your plots. The points and lines functions are there to add things to an existing plot. Add things, either add a set of points or add a set of lines to an existing plot. And there's actually a lot of these. Box plot can be used in this way if you want to add a box plot to an existing plot. There's polygon, segments, lots of different options out there. But just for example, I happen to know that when it produces a box plot like this, each of the values on the x-axis are just coded as the integers 1, 2, 3, 4, 5. So I could add points, and at the x values 1 and 2, and the y values 5 and 5. This should add a couple of points. I'm going to use my pointer up here at 1, 5 and 2, 5. Hopefully that works. Yep. So adding things, adding additional elements to an existing plot, enriching, the information content of a plot is pretty simple, pretty straightforward. Again, it's not the prettiest looking plot, right? This is not something that you would necessarily want to publish, but it's really helpful for getting a sense of the data.
That points to the box plot as opposed to like histogram that you gave.
It'll add them to whatever's active. Yeah, whatever's being viewed. So I'm pretty sure if I went back to here and did it, yeah, now it adds them here. Yeah. And yeah, 5 is much lower on this plot. Yeah. Okay. Those are the things that I wanted to say about plotting, because plotting is super important and it kind of got shortchanged on day one. Okay. Don't see anything from the folks online, so I think we're good to move on. What we're going to talk about for the rest of the day today is automatic reports. And yeah, never mind. I'm not going to show these slides because it's just going to be confusing. Rmarkdown is still around, but mostly in a legacy capacity. The people at Posit/RStudio have built Quarto, which is an excellent tool that it sort of encompasses everything that Rmarkdown did, plus a few other packages. And so Quarto is actually a really nice way to build PDFs and websites and slides and posters and all kinds of different things using LaTeX and R and Python and other languages that you might want to code in, all woven together in a single nice environment. And it requires a little bit of magic, which is what this is sort of showing. But and Word documents. It can also export to Word documents. It does a lot of stuff. And so, like I said, it's not Rmarkdown anymore, it's Quarto. Let's see how this magic happens. So in order to get this little box up here with an untitled R script in it, I had to go to this green plus arrow in the top left and hit new R script. If we want to start a new Quarto document, it's just the next one down. And this is going to open a little dialog box. As soon as it opens, where I can give my document a title, just call it my report. Say who's authoring this report. And if we want to make it an HTML, a PDF, a Word document, or we could even do other things. Beamer is for making slides. PowerPoint is obviously slides. Shiny is a really cool way to make like dashboards, interactive elements. But we're just going to stick to, for now, we're going to do an HTML because that's sort of the most straightforward. And all of these slides, you will notice that I've been presenting from are being shown in Google Chrome because they're all HTML. Okay. Yeah, so this should be all we need. Hit create. And that opens this new thing, which is a QMD file, which stands for Quarto Markdown. You don't really need to know that. This is just going to get in the way. Now it's a problem that I had to zoom in so much. But we'll just go through this really quickly. There's this box at the top, which is called the YAML box. I think it's some cutesy acronym, but I don't remember what it stands for. But basically this box at the top holds the metadata about your document. So title, author, and output format are the most important things here. All of these we've already set when we created this document. So you'll only ever need to change this if you want to change one of those elements. And then editor visual is just how do you prefer interacting with this document? So right now we're in the visual editor, but this is all actually based on underlying code. And if we want to see that, we can switch over to the source view and see like, oh, this is the code for creating that header that says Quarto. And then this is just regular text with these with these less than and greater than signs for a link. But there's no real like meaningful difference between the two. It's just two different ways of viewing the same document. So what does this allow you to do? It allows you to create like well-formatted reports that weave together text and code, as well as a lot of other elements like formal mathematical equations and things like that that you could get in a program like Microsoft Word. We can use, the drop-down menus up here at the top to do a lot of the types of formatting, again, that you would do in a word processor. That's how we get these headers. Or again, if you want to switch over to the source, you can use the double $sign to get a header. You can insert links through that drop-down menu, which is how they created this link to their website. And then the real power of documents like this is with what's called code chunks. So all of this is just regular text, right? That's all standard text. But if you go to insert executable cell for R or code block, I think it's easiest to just do executable cell and R. It'll create a new chunk like this. And these code chunks are where you would put your R code. I'm going to just delete this one. And so you can see they're starting out with a very basic example. Like I started out on day one with just using R as a calculator and demonstrating how that works. It's also possible to add options to these executable chunks. So here we're adding the option echo equals false. And that means when we render this document, when we actually turn this into an HTML document, we won't see this code chunk. We'll only see the output. That's just what they're explaining here. So I'm going to go ahead and save this. If you try to render it, so render is the way that you take this from the raw form that we see here into a final report or a final document. If you just click render, the first thing it's going to do is it's going to ask you, where do you want to save this? Because it always saves the raw document when producing sort of the output document. So I'm just going to go ahead and show you what that looks like. Right away, it'll pop up this, where do you want to save the document dialog. So I'm just going to save it in my home directory, call it report.qmd, again, Quarto Markdown. I'll save it, and then it'll start doing stuff down here in the bottom left. And there's my report. It created this nice little title block. We've got the section on Quarto, we've got the link to the website, and we've got some information about how to run code. And you can see, not only did it show this chunk of code that we had written, it also showed the output. So we didn't type 2 in there anywhere. It's saying it actually ran this block of R code and is showing us the output. And then we had that second code block where we said echo equals false. And so we don't see another code block here, but we do see the output of that block, which is 4, because the block was 2 times 2. So we see the output, but not the actual code. And that can be handy sometimes. Don't pay too much attention to what tabs I have open. Okay. One of the things that they don't demonstrate in here, whoops, that is very powerful, is plotting. Because like I said, you're often going to want to look at your data. So I'm going to insert another code chunk. Make another header. Say plotting. Here's how to plot Quarto. Okay. Going to insert an executable cell, an R code chunk. And now let's say I want to produce one of these histograms that we made earlier. The first thing I need to do is load the data. So Quarto is not, when it generates your report, it's doing that in its own little environment. So it's not connected to my global environment here. If I can pull this down. Yeah. So when I render this document, it can't see the diamonds data set unless I explicitly load it in the code for this document. So I'm going to go ahead and do that by saying library ggplot2 data diamonds. I don't necessarily need to see this, so I'm going to set echo false. That was not the right way to do it. It was like this. Yeah. Because, you know, that's sort of boring setup, right? Nobody really needs to see that code. But maybe my reader will be, you know, whoever's this report is for, maybe they'll be interested in seeing how I actually generated the histogram. So I'll just go ahead and make another block right below this. And this one I'll leave visible. And we'll say hist diamonds $. Okay. Notice the name of the document up top is in blue and it's got a little asterisk. That means you've got unsaved changes. So when I render it, it'll turn white and the asterisk will disappear. That means it automatically saved those changes. didn't automatically open, so I wonder if it just updated. Yeah, so if I go back to my browser now, it's updated my document. So we've still got all the same stuff as before, but now we've got this new section on plotting. And we say, here's how to plot in Quarto. Notice there's a missing code chunk here where we load the data. And then it outputs that histogram that we saw before in the RStudio plotter. If I want to do all of this, so HTMLs are nice ways to share things because generally everybody will be able to use it. HTML and PDF are really sort of the two universal document types, I think. Oh, we've got a question in the chat. If I share this QMD document, can others run this Markdown-based file without installing R? I don't think so. No, in fact, I know they cannot, because these R code chunks rely on actually running R code. So if you don't have R installed, you can't render one of these QMD documents. However, if you send them the PDF report or the HTML report, they'll be able to look at that, no problem, because that doesn't require re-rendering. That's sort of the rendered output. So yeah, that's a question very much in line with sort of the point I was making about HTML and PDF being fairly universal. So if I want to switch to PDF, it's as simple as replacing HTML with PDF and hitting render. This one's taking a while. Opened it in Chrome again for some reason, but you can see now it's a PDF document. And if I want to download it, I can download it down here. Or print it or whatever. And it looks pretty much the same. It's just on paper or on fake paper. One other thing that this is really nice for is just, well, I guess kind of the main point really is that this makes things very reproducible. If you have a particular pipeline, an analysis pipeline that you know you want to run on a data set, but you're still collecting that data set, or you're still adding things to that data set, this is a way that you can keep all of the code and analysis in one place. This could even be for, say a website. If you're trying to provide up to the minute analysis on a data set that is constantly growing, you could make a website using Quarto and just re-render the output anytime you add something to the data set. And you don't have to worry about, oh, how did I do this one part? Like, there's a lot of mental overhead that I've had to deal with that you no longer have to think about here. You don't have to remember, oh, how did I write this line of code? Or like, did I have a clever way of doing that? Or did I choose this option or that option? It's all right there for you. It's all fully reproducible. This isn't so much in the news anymore, but a few years ago, there was this big hype about the reproducibility crisis in science, right? Nothing reproduces. Here we can at least guarantee that the statistical analysis we run will be fully reproducible line by line, and anybody who wants to look at it can look at it. Oh yeah, one other, I don't know if there's a way to do this via insert. No. If you want your text to also update in real time, notice that, you know, the text and the code are kind of completely separate elements right now, but we can actually fully integrate them. Let's say that I've got some value that I've calculated from my data. And again, this is a value that might be updating as I change the underlying data set. And I want to include something about that value in my text, in my analysis. You can add, I think it's like this. Basically, the backticks that I did there turned this into a miniature code block. So let me just show that again. It's the backtick, which is under the tilde on most keyboards next to the 1. R tells it that this is whatever follows is going to be R code. And I could do, you know, any valid R code in there. But what I actually want is just whatever value is saved in X. I want to print whatever value is saved in X, but have it be part of my text. I'm just going to say X. And when I render that, should have switched back to HTML so that it would be faster. Scroll down to the bottom. We've got, this is a sentence about the mean, which is 0.7979397. And it's in the same format as the regular text. It blends in nicely. So we've got fully integrated text and R code. And as a bonus, for those who are familiar with LaTeX, you can use LaTeX notation and get very nice math format. But if you're not familiar with LaTeX, don't worry about it. Okay, any questions? That's pretty much everything I wanted to cover about Quarto documents. In fact, you could probably insert. Oh yeah, LaTeX math. How about that? Make a nice little math formula for you. Okay. Like I said at the beginning, I think R is a really, really great tool for a number of reasons. Particularly the fact that it's free and open source, right? You're never going to have to pay for R, unlike Stata, MATLAB, SPSS. And anybody can contribute. It's not controlled by a closed group. You don't have to ask somebody to make a new functionality for you. You can just make that functionality and then submit it as a package. The R community, I find, is very open and welcoming and accepting, particularly the bioconductor community. I'm an active member in sort of the bioconductor world, and I think they do a great job of embracing the openness, the idea of open source, and saying anybody who wants to can contribute. And yeah, it's really one of the strengths of R. Anything that you see in the world, any method that you see in a paper, you can generally find an R package that will do it for you. And you can usually count on it being written by one of the experts who, helped develop the method in the first place. There's been, I should have pointed this out earlier, one of my absolute favorite parts of the R community is the tradition of hexagonal stickers. I don't know if you guys have seen the back of my laptop, but it's full of hexagonal stickers. And I've got like 4 of them from packages that I've worked on. So if anybody wants to start their own collection, come talk to me afterwards. But I think we've pretty much covered all of the things. Yeah, this is all just like how to do it in the code. I don't think I need to go over, how to insert things using this code, right? When I inserted a LaTeX block here, you'll notice it added these double $signs, which is the special symbol for now I'm doing a chunk that is math, right? And when I inserted an R code chunk, it just automatically inserts an R code chunk for you. If we go over to the source, what that actually looks like is a triple backtick with curly braces and an R. But I don't think it's necessary for you to know that, given that RStudio has this really nice editor for you to use. So very much like importing data, I'm trying to give you the most bang for your buck in terms of, you don't need to know the code that does this, because practically speaking, you've already got the ability to do it just from the interactive elements here. So if there's anything else that people would like to know about, we've got about 15 minutes left. Oh, the cheat sheets. That was one other thing that I wanted to mention. I showed the dplyr cheat sheet yesterday. Posit, the company that owns RStudio, has actually a whole collection of really nice cheat sheets. They've got one on Quarto, if you want to know more about Quarto, Shiny, package development, all sorts of different things. RStudio itself, Rmarkdown, which again, don't necessarily recommend. dplyr, which was the one that I showed yesterday, ggplot2. Yeah, there's a lot of these really good cheat sheets. So if you're ever curious about, what can I do with any of these tools? What are sort of the possibilities? This gives a nice, pretty thorough summary of all the things you can do. And like I said, I have the dplyr cheat sheet bookmarked because it's extremely helpful when I need to combine data from different sources. But there are a lot of these. I think there's one on base R somewhere. I don't know if it's any good. But it's going to cover a lot of the same sorts of things that I covered on the first day. But they've got a whole block on how to read in data sets. Yeah, that's a really good tool to have in your back pocket. Okay, and with that, for real, I think I've said everything that I want to say. So if there are any other topics or things that people would like to revisit in the last few minutes, please let me know. Is it possible that we could get a recording? We're gonna get these recordings up on YouTube as soon as we can. I just don't know how soon that's gonna be. We are recording each of these sessions, so hopefully relatively soon. But in the meantime, the recordings of the sessions from previous years are available on the Biostats YouTube page. So if you just go to YouTube and search USC Biostats. Sad that we're not the first two options. I guess UC San Diego is paying for ads, so that doesn't count. We've got, just gonna control F for bootcamp. What? I know that we've got some. Oh, I have to go to videos. Yeah, we've got the 2021 version. And I think also the 2022, not positive on that. But those will follow the materials that I've sort of been presenting and sort of been ignoring throughout this entire thing. So it will be more focused on tidyverse in day 1, and it will be more focused on R Markdown in day 3, because at the time R Markdown was the most sophisticated way to generate these interactive reports. Okay, well, if there are no other questions or topics that people want to talk about, at least in front of the large group, I'm gonna let you go a few minutes early. Thanks very much. I hope that you found this useful. I hope that you got a lot of ideas for resources and how to find help when you need it. And, you know, feel free to reach out. I'm available. I have a lot of R experience. So, and I'm always happy to help people who have questions. So absolutely feel free to reach out, and yeah, I will see you around hopefully.